So today's opener is simplify each of the following square roots. It's what we took our notes over Monday and finished up yesterday. We're going to have 4 steps in order to simplify square roots. So I recommend having your notes out. That way if I call on you, you can tell me what step we're doing first or what the step is. So step 1, I'll get you started here. Step 1 is that you need to factor the radicand. And remember, the radicand is the number inside of your square root. So if I'm going to factor 70, what 2 numbers can I use?
7 and 10.
Okay, we can use 7 and 10. 7 is a prime number, so I'm going to circle it. And what for 10?
5 times 2.
And they are both prime, so I circle them. Now I'm going to come up to the right, so this is the second part of step 1, and I'm going to rewrite these as my radicals. So radicals means it's going to be under that square root sign. Now the whole purpose of learning how to do prime factorization and writing our numbers in standard form and then exponential form was because when you go to write your radicals under your square root, you need to put them in standard form. So you need to put them in order from least to greatest. So if I'm going to put these in order from least to greatest, it's going to look like what? Okay. That's step 1. Step 2 says to circle my factor pairs. Do I have any factor pairs here? No. So if I don't have any factor pairs, I skip step 2, which means then I have to skip step 3, and I go straight to step 4. Step 4 just says to simplify my inside numbers, which are my radicands, and my outside numbers, which are my coefficients. Well, I don't have any coefficients, so I'm just going to simplify my inside numbers. So what's 2 times 5 times 7?
70.
So the square root of 70 was already in simplest form. So when you go to do this on your worksheet, or if you have a problem like this on your quiz, I will still expect to see all of your work. How many of you guys got that one right? Good. All right, let's take a look at the next one. Do y'all have this down? So now we have 2 square root of 256. So now we have a coefficient. We're going to ignore that coefficient for the first part of step 1 and address it in the second part of step 1. So we're going to go ahead and still factor the radicand. So what 2 numbers can I multiply together to get 256?
16.
16 and 16? Okay. What times what gets me to 16? Oh, 2 and 8? That's fine. I'm going to use 2 and 8. You can use 4 and 4 as well. So we're going to circle our 2 for 8. What times what equals 8? Okay. My 4? Okay, we come to our other 16. Let's use 4 and 4 this time. Factor my 4s, they go to... Okay. So what are all my prime numbers here? 2. Yeah. So all my prime numbers are going to be a 2. All right. So when I come to the second part of rewriting these, what do I have to make sure I write first? My coefficient 2. So I need to make sure I bring this coefficient over and I write it down first. Then my square root and all my 2's. How many 2's am I going to end up having to write out? 8?
Oh, yeah, 8.
Are you sure?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. Okay. Yep, you're sure. 1, 2, 3, 4, 5, 6, 7, 8. Do I have 8 there?
Yeah.
All right, so that's my step 1. So my step 2, I'm going to circle my factor pairs. So how many factor pairs am I going to have here?
8.
I'm going to have 8 factor pairs? 4. 1. That's a pair. That's a pair. That's a pair. So now all of these pairs become, step 3, a single number in the coefficient. So I'm going to write my equal sign. The first number, though, I need to remember to put in my coefficient is my original 2. So I'm going to put 2 times. So how many other 2's am I going to have out in the coefficient? I'm going to have 4 more because this is going to cancel, come to a single number on the outside. My second one will cancel, come to a single number on the outside. My third one will cancel, come to a single number on the outside. Then my fourth one will cancel and come to a single number on the outside. So that's step 3. Step 4, you're going to simplify. So you're going to multiply all your numbers inside of your coefficient or outside of your coefficient. I have no numbers left in my square root, do I? No. So what's 2 times 2? So what's 2 times 2 here? 4. 4 times 2 is
8.
8 times 2 is 16 times 2 is 32. That's all right. You tried. So 32. So the square root, or 2 square root 256 equals 32. Any questions on that one? Do you have all of your work? Then flip it over. Let's look at the back. Did you have all your work done? All right. So the next one, we have the square root of 210. What 2 numbers can I use together?
21 and 10.
All right. Keep going.
5 and 2.
And then for 21?
3 and 7.
Okay, so I'm going to rewrite them as a radical. So it's going to be what?
2.
Do I have any factor pairs? No. So this one here is going to be just like the first problem on our opener, right? So what happens when I multiply all those prime numbers together?
Get it 210.
So it's just going to go back to the square root of 210, which means 210, the square root was already in simplest form. All right. And let's take a look at our last one here. So we have the square root of 1600, or the square root of 1600.
16 and 100.
So we're going to take 16 times 100. What times what equals 16?
8 and 2.
2 is prime.
And 4 and 2. And then for the 4 you put 2, 2. And for the 100 you put 10, 10. And then you put 2, 5. And 2, 5.
I thought 8 was a prime.
No. Because what 2 numbers can you multiply together to get 8? 2 and 4. Yeah. So it means it has more than 2 factors. So any number that has more than 2 factors is going to be a composite. All right, so now we're going to come up to the right of the square root of 1600 and write all of these numbers in our radical. So how many 2's am I going to have?
6.
So 1, 2, 3, 4, 5, 6. How many 5's?
2.
I mean,
What's wrong with how I wrote this? Yeah, make sure that square root covers all my prime numbers. So there's step 1. Step 2, I need to circle my factor pairs. So just looking at this, all my factor pairs are circled. So the square root of 1600 is going to be a what? If I have all factor pairs, I have no other numbers that's going to be left under the square root sign, right? So what does that mean, though? If we're not going to have any numbers left under that square root sign, it's called a what?
Perfect square.
Yeah, it's going to be a perfect square. So let's move to step 3 here. Move all of our factor pairs to a single number in the coefficient. So it's going to cancel, 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 and cancel. So I'm going to be left with what numbers for my coefficient?
2 times 2.
Keep going, Isaiah.
Times 2 times 5.
All right. I don't have a square root sign because they all canceled out with the square root sign. So I'm left with just a perfect square. So 2 times 2 is, times 2 is, times 5 is 40. What did you notice about today's opener?
We didn't, we did simple.
Yeah, 2 of the problems were already in simplest form, and 2 of the problems ended up being perfect squares.